So you probably wonder where this stuff all comes from. So it's the reverse of the product rule for derivatives, which is, as you all know, the derivative of two things, u and v, is equal to u prime times v plus u times v prime. Let's say we integrate it all. Let's reverse it. You get uv is equal to the integral u prime v plus the integral of u v prime. So we can subtract over uv minus the integral of u prime v is equal to the integral of u v prime, which is what we started with.
The topic we're introducing is integration by parts, and it's a BC Calc topic. And so sometimes when you have an integral problem, you can't solve it just by regular antidifferentiation or using u sub, and you need to use parts. So we pick a u, a v prime, and then from that we get u prime and v. So for this one, we're going to pick x as u and e to the x as v prime. So u prime is 1, and then v is e to the x. So then the formula we use for integration by parts is the integral of uv prime equals uv minus the integral of u prime v. So that would be, this problem equals u, which is x, times v, e to the x, minus the integral of u prime, which is 1, times v, e to the x. So then we just have x, e to the x, minus, and then the answer to the integral of e to the x is just e to the x. And then you can take out e to the x and get 1 minus, it's x minus 1, isn't it? X minus 1 plus v.
Okay, sometimes when you're doing parts, you'll end up with a problem like this, x squared e dx dx. And you're going to have to do that part by parts twice. So we need to pick a u and a v prime. So in this case, we'll make u equal to x squared and v prime equal to e to dx. We differentiate u to get 2x, and we integrate e dx to get e dx again. So if we take u and v, we get x squared e dx over here, and subtract the integral of u prime v, which is 2x e dx. But you see, this is, again, parts, so we parts this part. We'll make u equal to 2x, v prime, again, is e dx, and u prime becomes derivative of 2x is 2, and the integral of e dx is, again, e dx. So we end up with the parts of this is 2x e dx minus the integral of 2e dx. So we get 2x e dx minus 2e dx, and we just subtract that from this. So the final answer is x squared e dx minus 2x e dx minus 2e dx plus c. Okay. Now sometimes when you're doing parts, you'll end up with a weird problem like this, e dx cosine x. I'll show you one in a minute. So let's say we pick our u to be cosine of x, making v prime e dx. So we take the derivative of cosine x and we get minus sine x. And this is e dx. So we go uv, which leaves us with cosine x e dx, minus the integral of u prime v. So minus sine x e dx. We pull out the negative so you can make a plus. That's okay. So then we have the integral of e dx sine x. So you know we need to parts this again. We'll make u equal to sine x, and v prime will equal e dx. So we integrate sine. We know that's cosine. Minus cosine. And we take v, and we know that's e dx. So what we end up with is uv, which is e dx sine x, right here, minus the integral of e dx cosine x, right here. So, but if we take a look, e dx cosine x is the same as what we started with, so we can just add this to the other side. And that leaves us with 2 integral of e dx cosine x is equal to e dx cosine x plus e dx sine x. So we can pull out an e dx over here and then divide by 2 to find the integral, and you add a constant for it.
Everyone knows that the derivative of ln x is 1 over x, but how can you find the integral of ln x? Well, you can think of ln x as ln x times 1 dx. So then, for u, we're going to put ln of x, and then v prime is going to be 1. So u prime is the derivative of ln x, which is 1 over x, and then v is the integral of 1, which is just x. So then we have that equals u prime v 1 over x. Oops. No, it doesn't. It's uv ln x times x minus the integral of u prime v, which is 1 over x times x. So then 1 over x times x is just 1. And then the integral of 1 is simply x. So you get x ln x minus x plus v. Factor out the x in both, and you get x times ln x minus 1 plus c.
There you go. That's where it comes from.
Okay, so me and Espen are like BC Calc experts, so when we showed you all the examples, we already like knew what to pick for u and v prime. But what happens if, like, say the first example, which is actually our easiest example that we picked, what happens if instead of picking x for u and e to the x for v prime, you switched it around because you didn't know? Well, eventually you would realize how much harder it was to do it that way if you went through the steps. So say you didn't know what to pick and you put e to the x for u and you put x for v prime, then you'd get, for u prime, the derivative of e to the x, you get e to the x again. But then for the integral of x, you'd get 1/2 x squared. So then you'd have u times v, e to the x times x squared over 2, minus the integral of u prime v, which would be x squared over 2, e to the x dx. And then you would get all that over here, and then you have the integral, but then you realize that you have to do parts on that again because you can't solve x squared e to the x without parts. So then we'd make our u x squared, our v prime e to the x, and then the derivative of x squared is 2x, and the integral of e to the x is e to the x again. So then we come over here, and we have the whole thing written out, and then this is what we get. But we have our uv minus u prime v that we just did, and again, we can't solve the integral of 2x e to the x without parts. So we have to do parts a third time, and we get u equals 2x, v prime equals e to the x, u prime equals 2, v equals e to the x. So finally, we have all that was written over there, all of that, and then we have uv minus the integral of 2 e to the x dx. And that's finally when we can solve our last integral, which it just becomes minus 2 e to the x plus c. So we had to go through all that to get x squared e to the x over 2 minus 2x e to the x over 2 minus 2 e to the x plus c.
So basically,
if you choose the wrong thing, you'll have to do parts multiple times to get the right answer.
what she's trying to say is the objective is to get the integral, which is u prime v, as simple as possible. Because you would rather have 1 times e dx than 1/2 x squared times e dx, which is really complicated. So when you're picking the ones, you're trying to make u's derivative pretty simple. Therefore, the integral itself will be simple and easy to solve, which is what she's trying to say.